Flakes of snow stacked 2 feet high coat yards, fields, and roofs alike. Snowbanks rise with every storm, and likewise with every plowing. Winds jump into the frenzy, contributing their share to the sub-zero temperature. And Ashtabula County Highway Department employees are busy building a bridge. That's right, a bridge. And believe it or not, the builders don't even have to watch for ice on their bridge. Engineer John Smolen has developed a way to build timber bridges indoors. The process involves indoor fabrication of timber decks, which are designed to be supported on galvanized steel stringers. Over the last decade, Smolen's methods have been fine-tuned and improved, as his department averaged 3 to 4 of these indoor bridge projects per year. The Timber Bridge program not only allows county employees to stay busy between snow plowings, it produces bridges faster. And since the bridges are already constructed indoors, installation of the bridge takes less time. So when the sunshine of summer finally hits Ashtabula County, roads due for bridge repair or installation see less closing time and more traffic. Smolen believes the benefits of timber extend beyond the fact that using it for the decks keeps his crews busy in the off-season. He cites the fact that timber's relatively light dead weight compared to concrete generates less stress in the supporting stringers. Timber is easy to work with and does not require painting. It also serves as a renewable resource which is unaffected by road salt. Where concrete bridges give birth to potholes and cracking, timber bridges withstand even the hardest winters hole-free. The process of building these steel-supported, bolt-laminated timber decks begins in the drafting room with the planning phase. Relying on specifications from the American Association of State Highway and Transportation Officials as a guideline, Smolen decides upon the grade and species of timber, usually southern pine or Douglas fir, per national design specifications for wood construction, grade number 1 or better. Then, to determine the span length, he analyzes the size of the stream, drainage area, and watershed in square miles. Next, he checks into the spacing of the steel stringers, understanding that the wider the spacing is, the thicker the deck must be. These calculations usually result in a deck thickness of either 6 or 8 inches, depending on the spacing of the steel stringers. For this particular bridge, an 8-inch floor was used. Also taken into consideration in the planning phase is the design of the steel stringers, diaphragm, and guardrail system. Ashtabula County projects meet or exceed HS-20 loadings. The drafting engineers join in on the next phase, creating the project design on the computer. Once the plans are completed, they are submitted to the county engineer for any necessary revisions. After John reviews the plans, they are sent to the highway department, where the bridge construction crew takes over. The process begins in the garage with the construction of laminating bolts. To begin, workers take 20-foot lengths of 3/4-inch rod and cut the material into 48-inch lengths with a power bandsaw. A metal lathe, aided by thread-cutting die, is then used to cut threads into the rods. The threads are cut a bit smaller to compensate for the expected increase in thickness caused by the galvanizing process. To ensure a tight fit, the county workers consult with the galvanizer on the correct thickness. Taking a 3/8-inch by 3-inch piece of flat stock, the assembler employs an iron worker to shear the flat stock into squares. Then he uses the same machine to punch a 13/16-inch hole in the center of the square. Half of the resulting washers are welded to the unthreaded end of the rod and become the head end. The other half are used on the threaded end. Since the steel will be hot-dip galvanized, all cutting, drilling, and fabricating must be done before galvanizing. For this reason, steel is bolted together. All the steel material for the bridge is then transported to be galvanized. By degreasing the material in hot alkaline solution, galvanizers are able to remove oil residues. Then the material is pickled in a dilute solution of hydrochloric acid to remove mill scale and surface rust. The preparation process ends with prefluxing in a zinc ammonium chloride solution to give the steel holding power until it is transferred to the galvanizing kettle. The steel is then immersed into a molten bath of zinc, which results in a pure zinc surface on the steel after removal from the kettle. The hot dip galvanizing done on the county material meets the ASTM A153 and A123 standards. The next step in the bridge building process consists of creating timber panels. All lumber used for the panels arrives already treated with CCA, or chromated copper arsenate, a water-based preservative designed to guard against rotting. The retention rate of the preservative equals 0.4 pounds per cubic foot, according to the standards of the American Wood Preservers Association, with the specification being C14. Coming in at 3 by 6 inches and 16 feet long, the lumber is cut into the length necessary to ensure that all splices fall on the top flange of a beam when the panels are set on the bridge. Next, the crew members lay out hole spacing based on the pattern portrayed in the drawings by the office engineers. Usually, 2 laminating bolts are used between each stringer, with the splice pattern being set up to maximize the use of the timber. Using a single fluted bit, holes are drilled oversized to offer a better fit. A 3/4 inch rod will slide snugly into the 7/8 inch opening in the timber. Assembly of the panel begins on a steel rack, which serves as a bed to work on. The crew members put in the first row in the pattern and start a bolt in each one. Then they follow with subsequent patterns, working back until the whole panel is together. The outside boards are countersunk, being drilled with a 4 5/8 inch self-feed bit. This cut prepares the outside board to receive the bolt heads and washers. After the panel is assembled on the rack, a front-end loader picks it up and stacks the panel in a pile. The panel assembly process continues until all is completed for the particular bridge. A standard panel, 6 inches by 48 inches by 28 feet, lays 4 feet on the length of the bridge, with the bridge length being determined by the engineer's calculations. This particular bridge spans 18 feet and stretches 28 feet wide. Once the panels are completed, they are sent away for retreatment, this time with pressure creosoting. Being an oil-based treatment, creosoting reduces shrinkage, swelling, and the formation of gaps that are often associated with a water-based treatment. Creosoting works much the same as CCA, killing plant life and thereby preventing rotting. Panels are pressure treated to conform to American Wood Preservers Association's standard of C14 for a retention rate of 12 pounds per cubic foot. The creosoter vacuums the panels after treatment to prevent hazardous dripping of excess creosote. Up to this point, all of the project has taken place indoors. When it comes time to actually assemble the bridge, the process is carried on at the bridge site. After abutments are readied, steel stringers are placed on the abutments. Then the timber deck is placed on the stringers. Several methods of fastening the deck to the beams can be used. One method uses a bridge deck clip involving 5/8 inch carriage bolts. This deck clip can either be purchased or made in-house. Many of Ashtabula County's timber bridge projects have been completed with this method. On this particular bridge, however, a new method was used. Crew members use a Nelson stud welder to weld a 5/8 inch stud onto the top of the steel beams, 1 foot center to center. Then they place a 5/8 inch standard hex coupling nut on top of the stud. The timber deck is drilled and then placed over the stud nut assembly. To accomplish this placement, workers measure from the desired end of the deck to the first stud on the beam, and subsequently 1 foot to each stud. Measurement is then transferred to the deck panel, corresponding with the beam spacing. A 5/8 inch bolt with a washer is inserted through each deck panel hole, threaded into the stud nut assembly, and tightened as necessary. After the crew members lay a waterproofing membrane over the deck and pave the newly installed deck with hot mix asphalt, the bridge is ready to welcome travelers. And when the finished bridge meets its first patch of ice, you can bet the Ashtabula County Highway Department workers are back indoors building another bridge.